Okay, so let's now confirm that omega naught really is the square root of k over m. So here we have our mass on a spring, and according to the equation of motion, omega naught should be the square root of k over m. So we need those values. So for the spring constant, I measured it very carefully one day, hung some weights off the mass, looked at the position of the mass, and plotted the force due to the weights as a function of the displacement, and got a very straight line. Hopefully you can see that and be very impressed. And I got a spring constant of 16.35 newtons per meter. So that's k, the square root of 16.35. And the mass, it's a 1 kilogram mass. It says on there 1 kilogram. So omega naught, according to the equation of motion, should be about 4 radians per second. Square root of 16.35, 4.04. Now let's actually measure it and see what we get. So to get it a little more accurate, I'm going to measure 10 cycles, and then we'll divide by 10 to get the period. So I'm going to hold it down here and say go. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, 15 seconds. So when we measured it, the period was, let's see, it was 15 seconds, but we did it 10 times. So 1.5 seconds. So omega naught measured should be 2 pi over the period, 1.5 seconds, which, if you work it out, is about 4. About 4.1, 4.2. So equation of motion was correct. The natural frequency really is square root of k over m. That is the frequency this thing wants to oscillate at, no matter what amplitude and phase you give it.